In this video, I'm just going to show you a brief way of deriving the Henderson Hasselbalch equation. This is an equation that has a relationship between pH of a solution and pKa of a weak acid. So what we're going to start with is just a description of an acid. So we have our acid, HA, which is in equilibrium with H plus and A minus. This is really the hydronium ion, but then I have to include water. So I just have H plus and A minus. So that's the acid part, and this is your conjugate base. And the equilibrium constant for this reaction is the products over the reactants, which is H plus, concentration of the H plus, times the concentration of the A minus, so the conjugate base, divided by the concentration of the acid. And you can look at that and go, okay, that gives me the equilibrium constant. If I rearrange this equation a little bit and try and get this hydrogen by itself, so the H plus by itself, let's put H plus by itself. Now to do that, I have to multiply the Ka by Ha. So let's say Ka multiplied by the acid, and then divided by the conjugate base. So that's just rearranging that equation to have the H plus on one side. Why do I want to do that? Well, because now I can actually take negative logs of both sides. So if I take negative logs of both sides, I can go minus log of H plus is equal to minus log of this expression here. So Ka times Ha all on A minus. I'm going to put this in brackets and the whole thing in brackets so that you know it's a log of the whole thing. But there's something fun that you can do with these logs because you can separate them. So you can have minus log of Ka and minus log of Ha on A minus. So of the acid over the conjugate base. I could separate this further and have the acid over here, but really I want to keep this because I want to actually look at the ratio. Now, if we look at this a little bit more closely, minus log of H plus is actually just the pH. And minus log of Ka is the pKa. It's the same sort of thing. So we have the pH is equal to the pKa minus the log of Ha over A minus. And if I want to be a little bit neater maybe, or I don't like using minuses, I can also rearrange this in terms of pKa plus log, and when I turn that into a plus, I have to invert that. So it's going to be A minus all over Ha. So this expression here is just talking about the base, the conjugate base, over the acid. Concentration of the conjugate base over the acid. So that's the ratio. And this is called the Henderson Hasselbalch equation. And it's important because it gives you a way of looking at the pH of any acid and relating it to the pKa. So if you don't know the pKa, but you do know the pH and you know the concentrations, then you can work out what the pKa would be. Or if you don't know what the pH is going to be, you can predict what it would be for a solution. And this will be very important when you're making up your buffer, because you can use this equation, predict what the pH of your solution is going to be, and therefore what the changes in the pH are going to be when you're adding acid or base to it. So it's a very useful equation.